All right, hello everybody. This is Mr. Kimpton, and I'm going to give you a short video here on effects on climate, specifically ocean currents. This is going to cover targets 9 and 10. Uh, Target 9 is describe how the sun's electromagnetic radiation causes global surface ocean currents, and target 10 is describe how the Coriolis effect influences ocean currents. So let's take a look at these two. So I would first copy down this question below, and hopefully you can answer it at some point during this quick lecture or by the end of this video. So feel free to pause at any point in time so that you can get what it is that you need to get down in your science notebook. First of all, surface ocean currents. The surface circulation makes up about 10% of all the water in the ocean. So this is that top layer of about 400 meters of ocean that we refer to as the surface. The question that you need to ask is, how do they form, and what are the four main factors that cause them to travel in unique paths? So, how do they form? And the four main factors are all right here. The four main factors, or primary forces is what we call them, they are actually what start water moving. One is solar heating, two is winds, three is gravity, four is the Coriolis effect. And we'll talk about each one of these specifically. You should be able to, towards the end of the unit, be able to explain how each factor plays a role in creating surface currents. So, solar heating. We've talked about this a lot with our globe information and pressure belts and all that jazz. Unequal heating of Earth's surface causes warm water to expand at the equator. Water at the equator is actually about 8 centimeters higher than at mid-latitudes, so it bulges. And that causes a slight slope, and water wants to flow down slope, whether it's a bulge of water or a mountain. Cold water moves toward the equator, while warm water wants to move towards the poles. So you could think of it as kind of like a horizontal convection current. The second thing is winds. We've talked a lot about prevailing winds. Well, these help out by blowing on the surface of the ocean, and it pushes the water. So the water blowing along the surface creates friction, and this actually causes the water to pile up. It pushes the water in the direction that the wind is blowing. So the water will pile up in the direction the wind is blowing. You can see here in this picture the westerlies or the southwesterlies and the northeast trade winds, how these work together along with the Coriolis effect, and they create this circular motion out in the Atlantic Ocean. They call this a gyre. We'll talk about those in just a little bit. So gravity's role, it'll help pull that water down the hill. So if you see this bulge of water, not only does it bend, but it's going downhill and bends because of the Coriolis effect. So you get these huge gyres out here in the more open areas of the ocean, and those help to circulate those surface currents. So those are the really large currents, and you can see here how like the warm is going down towards the poles, and then the cold makes its way back towards it. So they'd all be doing this in this large gyre effect. And the Coriolis effect is what helps it all curve. It causes the water to move to the right in the northern hemisphere, so it would be doing the opposite of that in the southern hemisphere. So there's these, you can think of them as kind of like mounds of water. You wouldn't actually be able to tell, but there is a larger effect that goes on in this 400 meters surface water. So that's surface ocean currents. There's another question. It's not directly related to a target, but it's really good to know. Deep ocean currents. What causes deep ocean currents? They also call this the thermohaline circulation, which just is a fancy word for saying heat and salt. And actually, this actually makes up 90% of the ocean currents, or 90% of Earth's water in the oceans is actually moved through deep ocean currents. And they call this the global ocean conveyor. It really helps to distribute water around the planet. So, deep ocean currents. Here's one question that you should probably get down. They're caused by sinking waters. They form where the air temperatures are cold and where the salinity of the surface waters are relatively high. So you may ask, well, what makes some water saltier than others? And that has to do with the fact that when water evaporates or freezes, the salt doesn't go with it. So the salinity of the ocean water increases at the poles because salt is left behind. And at the poles, what is water doing? It's freezing. So the combinations of salinity and then cold temperatures make the water more dense, and it causes it to sink to the bottom. And now you have a deep ocean current. So here's a picture very much like the one in your book on page 58 of that great ocean conveyor belt. So deep ocean currents are caused by differences in density of ocean water. It's a vertical concept, okay, because colder water and more dense because of it's more dense because it's cold. It's also more dense because it has more salt in it, so it sinks, and you get this vertical, huge movement of water, and then eventually it's going to reach places where it has had the chance to warm, and it upwells, and that creates a large surface ocean current. So here in this picture, the red would be that warm surface part of the current, pardon me, and the blue part would be that deeper area going down along deep ocean surface. So deep currents move and mix the water around the world, which is super important for controlling our climate. They carry cold water from the poles toward the equator. This is also a huge contributor towards bringing oxygenated water deep down into our oceans for marine life. So that's about it for our ocean currents. Hopefully you've been able to figure out these two targets. Go back and watch the video again and see if you can find the answers to those questions if you haven't already. All right, ocean currents, some pretty important stuff. Have a good one.